Hello everybody. In this video, I will talk about analyzing experimental data when we have moderators. When these moderators represent individual differences, for example, individual consumer differences that we hypothesize will impact on the relationship between the experimental manipulation and the outcome dependent variable that we are measuring. What am I going to talk about today? I will first tell you about my practical recommendations for developing conceptual frameworks for the experiments. Then I will refresh your memory about the moderators, what they are and their types. And then we'll jump into the juicy part of analyzing continuous moderators. When it comes to developing conceptual frameworks for experiments, whether you work in academia or whether you actually do it for industry, your model needs to be very simple and crisp. You, for example, would have your experimental intervention, the manipulation, you would have your mediator, and then you would have your dependent variable, which is influenced by this mediator here. And you may also have a moderator, individual consumer difference, which impacts on this relationship, the relationship between your manipulation and your mediator. So this visually looks very simple, it's very crisp, it's very easy to understand. In contrast, this model is very, very hard because here you have your first manipulation from the experiment, and you are saying that it will impact the first mediator, then also the second one, and the first mediator will impact the second one, and then both of them will impact your dependent variable. And on top of that, you also have your first moderator, which impacts the relationship between experimental manipulation and the first mediator, and you have a second one which impacts this relationship, and this one impacts this. So this is a complete nightmare because it does not provide, first, a very simple explanation of consumer decision making or decision making reality. It's very complex, and you do not know what is it that is driving the behavior. So my recommendation here would be, please make sure that you have a very nice and simple explanation, because believe me, very often decision making is much simpler than we think about it. This is why here I have a big question mark. If you want to estimate something like this, it looks more like a survey research rather than experimental research, and I will highly encourage you to make your models much simpler. Another important aspect for the experiments is to actually think about your data analysis. If you do not have a plan on how to analyze your model, your conceptual model, how to turn this into an empirical model, you are really in for a trouble, and you will really suffer after you collect your data, which is not the best way to go about it. This is why having a plan is a really good idea. You can have a simulated data file with the parameters and answers for each of your measures, and you can play with it before you even do your experiment. I would highly recommend you to do that because it will help you solve future problems when you collect data and you don't know how to analyze it. This is the worst case scenario. Please don't do that. Also, try to understand the limitations and capabilities of different types of software programs that are available for us as researchers to analyze our data. And the questions here to consider are really about which software you shall use, because different packages have different assumptions and different capabilities. Some of them can handle non-normally distributed data, some cannot. Some of them can handle small sample sizes, but some cannot do that. Based on my experience, there are several software packages that you may use. The first one is AMOS. AMOS is based on maximum likelihood estimation, and it prefers much larger sample sizes because it wants to prove the structural model, which may not always be suitable to the experimental research cases. And it sort of prefers or assumes that data is normally distributed in your sample. If this is not the case, and if you do not have a larger sample size, and if you do not want to confirm the structure of your model, AMOS is not the best software for you. The other options that you may consider would include Smart PLS and Process Hayes adds-on to SPSS. Both of those software packages or processes as adds-on in SPSS can handle data non-normality. And they also can handle smaller sample sizes because they are based on bootstrap estimation, which means that they are trying to extract typically 5,000 bootstraps and from your original sample and then run data estimation on those bootstraps, which sort of accounts for instances when data is not normally distributed and also smaller sample sizes. Process Hayes has several templates which we can use to estimate our models. If you're not familiar with it, there are so many resources on the internet. You can look it up. And if you want me to make a separate video on it, I can. You just need to leave a comment down below. But that also means that there is less customization in Process Hayes models. And if you have more complex models and you would like to have a moderated moderation, then you may consider using Smart PLS because it allows you to custom build more complex models compared to Process Hayes, where you have to feed your data into the predetermined models, which were set up within this add-on for SPSS. Let's now briefly talk about a moderator and what it is. Here I'm using a different schematic. I have two manipulations. I have manipulation A and manipulation B, or a control group. And I'm saying that variations here will impact outcomes for my dependent variable. Now, the moderator is usually visually positioned right above the relationship. And usually we show it with an arrow dropping down on the relationship. And what it actually means is that this is a variable that changes the nature of the relationship between your predictor and your dependent variable in this case. And it can make it stronger, weaker, or completely annul it. And it may also change the direction. So it can make either positive or negative. So this is the moderator. It sort of moderates this relationship. It usually forms part of your hypothesis and your investigation, where you would say what the relationship is going to be like when you have this moderator. However, if you have a much more complex experiment where, for example, you have type of music, loud and quiet, as your first level of variation in the experiment, and you have another level of variation where you combine type of music with something else, let's say the color that you show, then when you model this type of data analysis, these two levels of variation in your experiment will be modeled as an interaction, but it will not be a moderation as such. It's just modeled as an interaction. Keep that in mind. Now, what types of moderators are available out there? I have already covered this in a separate video on this channel, but I will briefly refresh your memory in case you haven't watched that video. The first type of moderators that exists out there, and I'm talking again about individual consumer difference, is categorical or nominal. Here is an example. I am measuring whether people will respond differently to exposure to kinder schema or a control group, no intervention, in terms of how many cute labels or products they will keep. And I am saying that people who were randomly allocated to kinder schema manipulation should select more cute labels compared to people who were allocated in the control group. In this case, my moderator could be gender. And by the way, this is a hypothetical example. I made it up for the purposes of this video. But in this case, the moderator could be gender, where we could say that women will respond differently and they will select a lot more products compared to men when allocated to kinder schema, or they would select them even in the control group because they by default like cute products. And another example for the categorical or nominal moderator is when we have preference for cuteness. We ask people whether they like, yes, or dislike cute things. In this case, this again acts as a categorical or nominal moderator. And in this case, we are hypothesizing that consumers who like cute things, they will select more cute products compared to those who do not like cute things. And this will also be impacted by the manipulation to which they are allocated. And this is exactly what's captured by hypothesis number 3. Those who like cute things will prefer more cute products and cute labels compared to those who do not like cute things. So this can also be a potential direct path, and this is my moderation path where I explain how people allocated to Kinder schema will choose their products depending on their individual preference for cuteness. Now let's have a look at how this type of a scenario should be analyzed. Usually when we have nominal by nominal moderator and we have nominal manipulations, we can run a 2 by 2 ANOVA. And there is a really good example in this paper here if you want to read about this. And the beauty of ANOVA is that you can actually model these interactions, the interaction between the manipulations and the moderator. And you can also model the direct path of the moderator on the dependent variable and direct effect of the manipulation on the dependent variable. Now, this is very easy to model. If you would like me to make a separate video about it, please let me know in comments. Now, let's talk about more complex situations where we have continuous moderators. Continuous moderators, as the name suggests, have different level of measurement. It can be ordinal, interval, or ratio. Using the same example with Kinder schema, let's say this time I ask people to measure their preference for cuteness using an ordinal level of measurement, where 1 stands for I do not like cute things and 7 stands for I like cute things. This is an example of a continuous moderator where we're still hypothesizing that higher preference for cuteness would strengthen the relationship between Kinder schema and the dependent variable, or it will result in greater number of products with cute labels chosen, in other words. So this is what I am hypothesizing over here. And how can we analyze data? In this case, that very simple model can be analyzed using Process Hayes add-on in SPSS using Model 1. And if you're not sure what Model 1 stands for, you can read this really good resource, which I have here, and you will know a lot more about modeling Process Hayes models with SPSS add-on. You can also try ANOVA, and this is what a lot of people would try to do in the first place. They can model this as a covariate. But one thing to keep in mind here is that if you run an ANOVA, you cannot model the X and a moderator interaction in the plot, so you cannot produce a really nice visualization. So my recommendation would be run a simple ANOVA with fixed effects, not random effects, because if you do it in random effects, again, it will be very hard for you to produce the visualization. Why are we after the visualization? Because we really need to understand what's happening with the scores and the dependent variable depending on different levels of our continuous moderator. And later in this video, I will show you really cool hacks on how to make such a visualization and make sense of your data. What happens sometimes is that researchers tend to dichotomize the responses because they are, of course, easier to analyze because then it would look like more like a nominal variable and it's much easier to model and visually it looks easier to understand. So this is why I have here arbitrary lower preference division and higher preference division. And very often researchers do this because it's easier to interpret. And what happens in this case? You basically, if you look at Bayron and Kenny, you're moving from case 3 to case 1. So from continuous, you move into sort of nominal type of a moderator. When it comes to this dichotomization, there are different approaches. Some people use median split, so they find a median score and they split on that median score. This is really problematic because if you have non-normally distributed data and your median is at 5, there is no point for you to dichotomize it on 5 because 5 is actually leaning towards higher range of the scale. So median split by default is really not a great idea. Also, median split has been criticized past years, even though dichotomization is very popular in marketing, and marketing researchers have been doing it quite a lot. And research suggests that around 46% of articles published in the Journal of Marketing Research and Journal of Marketing and JCR, Journal of Consumer Research, in 2003 were using dichotomization. Popular method for the dichotomization was picking a cutoff point, which was really done randomly by the researchers, or dividing other middle of the scale. So if I go back to my previous example, researchers would divide responses on the middle of the scale because they would say, well, naturally, this sort of leans or falls into the category of a disagreement or disliking of cute things. This is kind of midpoint, so I will actually split the responses on midpoint, sort of makes sense because here I have the agreement. So this very seminal and important work published in 2003 suggested that this was a very popular tool. And what is being recommended instead at the moment is to use continuous variables as they are for moderators. There's also another paper which was published in 2008 by Fitzsimmons, and this is what they call in the article death to dichotomization, especially for the experimental research. So when you are considering your experimental designs, whether you're going to have moderators or not, it's important to think how they will be captured and how they will be analyzed. So the issue of dichotomization could become an important one for you. And my recommendation for you would be to use the continuous variables as they are. If you're not familiar with this works, I have put some citations here for you to have a look when you have some spare time. So now the question is, how do we actually analyze continuous moderators to make sense of data and also visualize it? Because the key to understanding data is actually its good visual presentation. Let's have a look at an example. The example I'm using is the training data that I have. It doesn't come from any publication, and it's about corporate social responsibility. Let's say I run an experiment, and in one condition, I tell people that a company is spending more on corporate social responsibility, let's say 10% of their pre tax profit. And in another condition, there is a smaller CSR spending allocation, which is 1%. And then I'm trying to see whether there are different measures or there are differences in brand attachment, in how people respond to different types of information about CSR by companies. But then I'm also saying that this relationship between CSR spending and brand attachment may be influenced by how important CSR is to consumers. So I expect there would be individual consumer differences that will impact on that relationship. Let's have a look first at data analysis with ANOVA, and I will run it in SPSS to show you different tricks that I use for data visualization. Now I am in my training data file, and let's run ANOVA. There are two options that you can run ANOVA from in the SPSS software. The first one is via compare means and proportions. You have one-way ANOVA here, and also on the general linear model, you have univariate. There are big differences between these options because if you select this one, you will not be able to model the interactions. You can only model your independent variable here and your dependent variable. So you can model the interactions and moderators only if you go and select general linear model univariate, because here you have an option for your fixed factors, for random factors, covariates, and also for data weighting if that is the case. So what I need to do now is to actually get my independent variable in here. It's condition S1 dummy. This is my fixed factor. Then brand attachment is my dependent variable. And then I have CSR importance, which is actually my continuous moderator. I usually put it in fixed factors because I like to see the interactions in plots. In the model, what I want to do, I want to model the direct effect and also the interaction. So I clicked on this one and Control Shift, and I have just created an interaction which is designated by this cute little star here. Then we click Continue, and in the plots, I actually want to see the visualization. I create the first chart just for the manipulation, and then the one for the CSR importance, which is my moderator. Now, with this in mind, I think we pretty much ready. I just need to select few additional options here and post hoc test. Maybe I will select this one, but it may not run it because there are only two groups here. So maybe I will just not use it this time. And now we are ready for our data analysis. All right, let's have a look at the results. We have this very long table where we have now for the first experimental condition, different levels of CSI importance, and we have the mean, and you can see the spread over here. So that looks really overwhelming and not very straightforward, but then you also have your total mean here. And total mean for the first condition is right here, and for the second one right here. Test of between subject effects is what we look at to see if the effects, the direct effect, and the interaction are statistically significant. What you can see from this significance value is that it's actually null hypothesis. There is no difference between larger and smaller CSR spending between 1% versus 10%, but there is a statistically significant interaction. And then you also have parameter estimates table, which a lot of people overlook, and they do it because this looks a bit overwhelming and cognitively loading. Because what you've got here is you actually intercept. This is the score for the y variable when your x variable equals 0. And then you have pretty much a score for each of my conditions. I coded them as dummy variables. That's why I've got 0 here at different levels of CSI importance. Here I have it at 2.50, 2.75, and so on and so forth. It's a very long table, and then you can see that I've got significance levels produced for each different level. And you can see that as I scroll down and my scores actually increase on CSI importance, they becoming not significant at 6.75 and also at 6.25. And on all occasions, the beta coefficient is actually negative. Let me show you the rest of the table and then what I usually do for this type of analysis. You scroll down and then here you see that I have my second dummy variable coding, a score of 1. And again, it has been analyzed at different levels of CSR importance at 3, 3.25, and so on and so forth. And you can see that at some levels, it's not statistically significant. At some, it is not statistically significant at 0.5. At 5.25, not statistically significant. At 5.50, not statistically significant. 5.75, 6.25, 6.50. So obviously something is going on. Then you scroll down and you have the effect just depending on the condition, larger and small spending. And then you have a more detailed visualization where you have different levels of CSI importance. Now, this is actually very hard to understand because even if you visualize this and you double click on it and then right click and say show data labels, that will become cognitively overloading, and still it's very hard to see the trends in this data. So this is where a lot of researchers actually give up and they say, I don't understand this. That's why I will go and I will dichotomize on the media or on the mid scale, which is not the best approach, to be honest. How do we make sense of it? Let me show you a few little hacks and tricks that I use. What I usually do, I take this table and I put it in Excel file because in fact, this is your regression analysis. It is a regression analysis because ANOVA was developed in the field of psychology. And this intercept here is a score, which is your constant from the regression equation. And it's a score of the dependent variable when x variable equals 0 if you have your x-axis and y-axis. So you can actually use this constant and the scores right here because these are your betas in the equation, regression equation, to calculate your dependent variable. So here, for example, you would take score of 5.33 over here, and then plus and negative score over here. It means that the you have to subtract it, and that will be your actual dependent variable. So let's have a look at it in Excel file because it's so much easier to convert this and do those estimations in the Excel file. Over here, I have my Excel file. So what I've done, I carried over the scores on my moderator on CSI importance into this column. You can see that it's 2.50 here, 2.50 to 7.5 is here. And then I have my brand attachment column here where I've calculated the scores. Here is the formula. You basically, if you double click, you'll see that I've taken this score and I have added this to all to the first score in here for 2.50, and I fixed it so that it remains the same. And then I've clicked OK, and I dragged it underneath, and there I've done my calculations. So now I have a really nice and clean data, or I can see that at the score of 2.50 for CSI importance in the smaller condition of CSR spending, the brand attachment is like this. And then what I've done, I've just visualized that I've made a nice line chart. When I selected all the scores, I produced this one. And I've also done the same thing for the second condition that I had in the experiment, larger CSR spending. And I've done exactly the same thing when I calculated the score for the brand attachment. Now, let me show you how I would interpret this result in overlaying those visualizations. So what I've done here, I've taken this chart and I'm trying to make sense of it. I know if I look at the individual scores that I've got statistically significant effects at the lower scores for my CSR spending. And I know that after score of 6 on my CSI importance to consumers, I have non-statistically significant effects on the brand attachment. So what it actually tells me is that there is somewhat increasing upward increasing trend, but after 6 on the CSI importance, there is no effect on brand attachment anymore. I kind of see that from here it's sort of increasing. Maybe it's increasing from here. Here's kind of flat, but there is a bit of a spike over here. This is what I see for smaller CSR spending at 1%. Now let's have a look at 10%. This is the visualization for another experimental condition. And here I can see from the table, which I've shown to you previously, that there are statistically significant effects all the way up from 3 to 5. And when it becomes 5 on CSI importance, in other words, CSR is becoming more important for consumers, then it becomes non-significant after point 5. And when I overlay these two visualizations together, this is what I have. And by the way, I changed the color. So my larger spanning is in red color and my smaller spanning is actually in blue color. And remember, the interaction between the condition and the moderator are statistically significant. When I try to make sense of all this visualization, this part looks very messy because here I cannot see a clear trend. I can see that brand attachment is actually slightly higher at lower CSR, but at larger spending. But then it drops, and here it becomes again higher compared to the smaller allocation. But overall, it's very messy here. And what this part actually tells us, if you visually investigate it, is the following. When CSR is less important to consumers because we are looking at the lower end of the responses, it actually doesn't matter how much they allocate to CSR in terms of brand attachment. So if it's not important to them, if CSR is not important to consumers, you can allocate as much as you wish. However, when CSR is becoming more important to consumers, you can see clear trends. There are differences between smaller CSR allocation condition and larger CSR allocation condition, because here you can see clear difference. Brand attachment at 3.46 versus 4.56 when it's around 525, and then 522 is much higher brand attachment when CSR is more important to consumers in a larger spending compared to a smaller one. So this is where you have a much clearer understanding and a more interesting story in your data. It actually shows you that it pays off to spend more to CSR when the consumers value it more. And by the way, this is training data. So this is what you can get if you produce those dependent variable effects. You calculate them in Excel file and then you chart them and visualize your data. Now let's have a look at Process Hayes model. Let's do exactly same estimation, but in the Process Hayes model. This time we will run model number 1. So I need to click to analyze, and under regression, I need to find Process Hayes. I just need to change this to variable names. Then I'll scroll down to where my variables are. I have dummy coded my conditions and it goes into X. Model is model 1. You can see there are other models available out there. Brand attachment that goes into the Y variable. And I don't have any mediators because it's model 1, very simple. But I have my CSI importance, which actually goes into the first moderator. Important thing to keep in mind, not this one, but the long variable names, it has to be ticked. Otherwise, the software will keep producing errors for you. And the option, what is very helpful, is to select show covariance matrix of regression coefficients, generate codes for visualization. This is very, very powerful. Show total effects, although it doesn't apply to model 1, but I still ticked it. Effect size, standardized coefficient, and I would like to see this one. Then we click OK and then OK again. And the software is then running this for us. Now, here is the actual output. You see that the first outcome variable is actually brand attachment. Around 28% of variance was explained by this model. It's statistically significant. Here we have the results. The condition is statistically significant and it is negative, and you have to interpret this as a dummy variable coding. This is the CSR importance modeled on its own. It's statistically significant and it's positive. Basically means the high is CSR importance, the high is brand attachment, and the interaction is also significant. What is important here though is this code here. You just need to select it and copy paste it into your syntax and run this for a visualization. You just need to double click in the space over here. Then this whole output becomes active. You select this whole code starting from here and you press Ctrl C on your keyboard. You select new syntax file. You paste this into the syntax file and then you run it. It will generate a new data file and another output for you, which is the visualization. Now I have made it look nicer and I color coded and I put the actual coefficients here. And I will just go back to my PowerPoint slides to show you which visualization these can produce for us. This is the visualization that I slightly edited in SPSS. My smaller allocation to CSR is in black color and higher CSR allocation or spending is in red color. And here we have the scores for CSR importance. It starts at 4. It's very important to understand how these scores are being produced by Process Hayes. For example, this is the annotated output. This is what I'm talking about at the moment, this syntax code. I have here a score for my dummy coded variable. 0 is 1%, 1 is 10%. And then you wonder, why do I have 4 here, 5 and 6? And you can see that this 4, score for your CSI important, is being calculated for each of those conditions. And then you have the score for your brand attachment. But you wonder, do these represent the points where statistically significant effects have been observed? No. Those points are selected randomly by Process Hayes for you based on the actual distribution of the scores in your data. So that may suggest to me that I have scores in my CSI importance which are skewed towards more positive responses because I don't have any ones, I don't have any twos, threes. So what's important is you actually check the distribution of data for your responses. And I've done it. I have mostly answers skewed towards the positive end of the answer scale. And this helps us to interpret this chart because this explains why everything starts with 4. It's not that the effect is statistically significant at 4. It's just the software picks those points to show us the visualization. And what you can see here, again, sort of does not make sense because brand attachment is lower when the company spends less on CSR. It's actually higher when company spends less on CSR. But as you move from lower CSI importance to higher CSI importance, you see that those differences become smaller and absolutely negligible when CSR is super important to consumers and here you can see that brand attachment is very similar for both. So what does it actually tells us if we put this into managerially relevant interpretation? It means that larger CSR spending does not pay off when CSR is less important to consumers. Over here, if it's less important, when you spend more, it doesn't necessarily drive the brand attachment. And you can see that it slightly becomes different when CSR is becoming important, but differences in brand attachment, they reduce as the CSR important increases. And here again is very interesting. Here again, it doesn't matter how much you spend on CSR as long as you spend on CSR because it is super important for you. So this is how you interpret the results in this very interesting training dataset file that I have for you. One interesting point to keep in mind is that you may have noticed that results of Process Hayes does not match the results of ANOVA. In ANOVA, the effect of the manipulation on its own was not statistically significant. But here in Process Hayes, it became statistically significant. Why that's the case? Well, because Process Hayes is based on slightly different estimation, and it's using 5,000 bootstraps to calculate the effects. So it creates 5,000 random samples from your original sample. So this is why there could be differences between ANOVA results and Process Hayes. So if you're using different tests to analyze your data, please be mindful that you may have different results based on the analytical approach that you use. Now, what I would like to do is to show you how to run Model 7, which takes into account the full mediation with brand attachment as a mediator and repurchase intentions as the dependent variable. And this is called moderated mediation because you also have a moderator. I will now show you how to run this quickly as PSS. As always, we go to Analyze, Regression, and Process Hayes add-on. Now we need to change this to Model 7 and find the dependent variable. And dependent variable is actually repurchase, and we need to put it in here. So Y now becomes our mediator, and repurchase intentions becomes our dependent variable. Now we run our analysis again, and let's have a look at the results. This is the first output, and you can see it's exactly the same as in model 1 because nothing changed in that part of the model. What is more interesting for us is repurchase intention, outcome variable, and you can see that Process Hayes cuts off the variable names if they are more than 8 characters. So please be prepared. This is something to keep in mind. Then we can see that overall, I have a very small percentage of explained variance. It's just 2% here, very tiny. And over here, condition on its own is not significant, but brand attachment is significant. And the lower it is, the higher is repurchase intention. Now, this is a very strange results because that does not make any sense. But like I said, this is training data, and I'm just interpreting this using the statistical effects that we have. And what we are looking at, if results actually made sense, we would look at the indirect effects, which is right here. Condition influencing brand attachment, influencing repurchase. And here we have again our CSI importance scores, and there are 3 of them, 4, 5, and 6. And you can see the effect on the repurchase intentions via brand attachment through the condition at these different levels of CSR importance. This one is slightly harder to interpret because there is no visualization. Visualization was produced only for the other part for us. And here we have to interpret those coefficients, always bearing in mind the dummy coding. But one important thing to keep in mind is that none of those effects are statistically significant because there is a 0 here, right? If both lower and higher confidence intervals had positive or negative scores, then I would say it's statistically significant effect. At the moment, it's not. And this sort of explains why this is negative because that sort of doesn't make any sense. The higher is the brand attachment, the higher your purchase intention. But like I said, this is training data, and we're just going to go along with what it's given to us. And here I wouldn't interpret it much because there is no statistically significant indirect effect of condition on repurchase intentions via brand attachment. But if you want to understand what these ones are and what they mean, these are the effect sizes on repurchase intention. And what it actually tells us is that at lowest CSR important, which is 4, the indirect effect is positive and it's slightly larger, right? Because 0.08 is greater than 0.03 and the last one. But again, this is not statistically significant. So you have to be very careful while interpreting non statistically significant results. I do not encourage you to do that. I'm just telling you how to interpret and make sense of your data. Then it says that at medium level of CSR importance, which is 5, the effect is becoming smaller and it's becoming negative and absolutely teeny tiny, non-existent at higher CSR importance levels. And these are the effects on repurchase intentions. But what I just wanted to show you is how to run Model 7 using Process Hayes add-on if, for example, you wanted to estimate such a model in your experiment. The last piece of information, food for thought, that I will give you today is an example of Model 7 when I dichotomized CSR importance, and I have done that on the median split. So I ran the model, and you can see that for my brand attachment, results are very different. The condition is not statistically significant. Interaction is not statistically significant. It used to be before when I use a continuous moderator. Now I lost it, and only CSR importance on its own is statistically significant. So it actually shows you that you may get even worse results when you dichotomize your data because you have artificially split it into low and higher pots, which is not always ideal. And let's look at the rest of the output for the dichotomized CSR split on the median split. This is my visualization. I took this code, I visualized it, and this is how it looks like. This is my dummy coding, lowest CSR importance versus highest CSR importance. And here I have different spanning. And as you can see, I do not have a really nice clear cut picture here. So my recommendation for you would be do not dichotomize, just use continuous moderators as they are. Last consideration which I wanted to highlight today is that Process Hayes provides templates only. So you have to feed your experimental data and your models into those templates that are available. If your models are more complex, you may need to find another software to run your analysis. And in this case, you can use Smart PLS because it allows you to model more complex experimental models in there and achieve similar results as in Process Hayes because you can model continuous moderators there and you can model them at plus or minus 1 standard deviation and 0 at the mean for your samples. One thing to keep in mind though is that Process Hayes allows you to model several mediators, but if you're trying to build much more complex models, using your experimental data, you may switch to Smart PLS in this case because it allows more customization. You don't have to work around the preset templates. Now, this is everything that I had for today. I hope now you understand how you can visualize your moderators, especially if they are continuous ones, and then you can understand how to find the effects through those visualizations in your data and make sense of your data overall. Thank you so much for watching. Subscribe, click the like button, and I'll see you in the next one.